Okay, so guys, what we're going to do today is we're going to revisit the last topic that we did when we were here last time. So, to do that, the last time we were here, we looked at the gradient. Remember that gradient has another word. Gradient can also be called what?
Slope.
Slope, exactly. And it's just how far up or down a line goes, right?
I already know how to calculate the gradient.
So, pardon?
I already know how to calculate the gradient.
Right, because we covered it last time we did this, right? Remember that we had rise over what? Rise over run. Excellent. And when you're counting out the rise over run, remember we have different methods for finding the gradient. If you have the graph, right? You know the graph. Then all you need to do is just count from one point to another. But remember, when we're counting out from one point to another, we want to count it. We don't want to, remember, Education Perfect just counted one across, but that's not always the case, that you're going to be using just units of one. So instead, what I want you to get in the habit of doing is counting them as rise over run. Is rise always mean up?
No.
No. If rise can go down, if it's what kind of number?
A negative number.
A negative number. Excellent. Do you always go to the right?
No.
Nope. You can go to the left, but if it's what kind of number?
A negative.
A negative number. Okay? Good. Keep that in mind as you're moving forward as well. So what we're going to do is we're going to go into the Education Perfect lesson here and just show you some of these, and so you can practice them. Remember that all you're going to be doing is exactly the same thing we did last time, but this time, instead of just counting in points of one, then you can choose any point on the line. And many times in the graphs that they gave you last time, they gave you the points instead of, but this time you're going to get to choose those points. And remember, you can choose any points on the line as long as it's where they cross one of those grid lines so that you can tell easily what number it is, right? You can't go where it's in the middle because you don't really know what fraction that would be. Sure.
How many Education Perfect were there to do?
I'm not sure. We'll look at it in a bit. Okay?
24.
All right.
At the same time.
So, calculating the gradient. So remember that in the lesson introducing slopes and gradients, you learned that you can find the gradient on the line by looking at how much y changes as x increases by 1. But you can also calculate it when the pieces are further apart. So if you look at this particular graph, you can see that they've given you 2 dots just like they did before, right? But these dots are way further apart than just 1 unit, aren't they? But it still doesn't change the process. All we're going to do is count from one of those points to the other. And we're going to do it as rise over what?
Run.
Rise over run. Get in the habit of always going up or down first and then
Left or right.
left or right. Good. So if I start here at 4, in order to get up here to the 10, I have to go up how many units?
6.
6 units. So that tells me that my rise is 6.
Mm-hmm.
But now I have to get from this point to the right, how many?
3.
3. So that gives me a rise of 6
And a run of 3.
and a run of 3.
Is that one? This is not the where you died. Or is it?
No, it's not up there yet.
Which one?
Right.
Oh, it's
Okay?
not there.
It's not up there.
We can still find it.
No, I don't want. Now, though, I've got my rise and my run of 6 over 3, but am I done?
No!
What's wrong with that fraction?
I've got no idea. It's just when it's not 75. Wait, no.
All right, Charlotte, I know you know this because we did that. Yep. Remember what happens when you have one number on top of another number? What does that mean to do?
Divide it by that.
It means divide it, right? So 6 divided by 3 is going to give me what? Anyone? 2. There you go. Good. So my finished answer is 2. Okay? Now, 2 is really a fraction, isn't it? Even though it doesn't look like it? Exactly. We can write any number as a fraction by simply putting it over 1. But even though 2 over 1 and 2 are equivalent, which one is the preferred one?
8. The simplified one.
The simplified one, so just the plain old 2.
2.
Okay? All right. So make sure that you're putting it in as just plain 2. Okay? So 2 over 1 is the equivalent, but the simplified form is 2. Okay? Good job. All right. So,
Good job, kids. You're a child as well. No, I'm not. No, I'm not.
all right.
Yes, I can.
So then they're just walking us through this same problem. Counting out the rise and the run. Sorry, it's a little slower when I do it remotely.
I'm terrible at drawing graphs.
Let me do it up here.
I'm probably just going to erase this when I'm done because I just waste my time doing that.
So there they go. Now they do it along and up, but I don't want you to do that. Remember, like the stairs, do you push your foot forward first or do you lift it first? Lift it first. So keep that in mind. Okay? So they find the gradient. Okay? All right.
Oh, yeah.
Okay? So then they start doing it as rise over run. They start introducing that idea, but we've done that. So let's look at this particular graph. Okay. So look at this particular graph. Now, they're asking us to find the slope, which we're going to do by counting the rise over run. But what's different this time? What do you notice?
That, it's listing.
Okay, well, it's sloping, but what do you notice about the line that's
blue.
different?
It goes through the
Okay. So it's going, right? What did they give us last time that they did not give us this time?
The dots.
Exactly. They didn't give us any points to count to, did they? Okay? But do they have to give us actual points to count from?
No, we can find them all by yourself.
Right. And does it matter which points you choose?
Yes.
Well, does it matter really? No, it really doesn't matter as long as they're where?
Up. Down. Left.
On the grid lines, right? At the intersections of the grid lines. Excellent, okay? So what I want to do is I can select any points on this graph as long as they're on the grid lines. So could I choose a point right here?
It's frozen.
Right there?
No, it's not frozen. No.
Why not?
Because it's not on the grid line.
But it's on the line.
But it's not on the grid line.
Exactly. It's got to be on the line and on the grid line. Good, excellent.
Oh.
Could I choose this point?
Yeah.
Yes, because it's on the line and it's on the grid line. Okay? How about this point? Would that be okay?
Yeah.
Yeah, because it's on the line and it's on the grid line. So it doesn't matter which points you choose as long as they're on the line and on the grid line. The reason why we can't choose the point that I chose at first, this one, is because since it's not right on a grid line, I don't know. It looks like it's at 1/2, but I can't really tell that, right?
It might not be.
And,
because
right.
It's also really splotchy.
It might not be. And plus, do you like working with fractions or whole numbers better? Whole numbers. Okay? Right. So, there you go. So now what we're going to do is we're just going to count this out as rise over what?
Over run.
Rise over run. Now notice I keep writing that out, and that's what I expect you to do. So first I'm going to do the rise. In order to get from this point to this point, I need to go up how many units?
I don't know. 4.
Ooh, be careful. Count more carefully. 1, 2, 3 units, right? I'm going up 3 units. And then to get from this point to this point, I need to go to the right, what?
6, 5, 6.
6 units. There you go. 6 units. And am I done? No, because 3 and 6 Now, can I divide a 3 divided by a 6? No? No, but what can I do to it? I can simplify it or reduce it. Right. What number will divide evenly into 3 and 6 at the same time? 3. They have a common factor of 3. That means I can divide them both by 3. If I divide 3 by 3, what do I get? 1. If I divide 6 by 3, what do I get? 2. So what is the slope of this line?
A half.
1/2. Exactly.
Which is pretty much just 1/2 of 1.
Okay.
Which is like...
So 1/2. Now, could I write that as 2? No, because this time the 1 is on the top and the 2 is on the bottom. So it's 1/2. So, okay. All right. So we have 1/2 is our answer. Okay. I don't see any writing on there. I want you to go into other spots, please. Okay. All right. So here we go. Let's go back to our Education Perfect and see if we can find one for you guys to do.
Can I do that? Can you just tell us if it's around the walls?
No. It's not in this classroom.
You bet, but it's also going to be in the recording, you know. Okay, guys. All right, now, something else about this is we found the slope, and they're also asking you to answer a question about that slope. And if you look at this graph, what it's measuring is the distance in meters over the number of seconds that this person traveled, right? So that gives us a rate per second in meters per second. And remember, anytime you see that word per, okay, what do you always think of when you think of per?
I think of perfect.
Well, no, be careful. Here you go. This has a per in it. Which thing is the per?
The one. Yeah, the one.
No, be careful. It's the fraction bar, right? Okay. All right. So, right? What if the slope is negative? What does that mean? That the line is going what? The line is going down, exactly. And so you can have slopes where you count the rise as down. And so make sure that when you're counting these, then you count them in the right direction, right? So if you look at this particular one, in order to get from this point to this point, I wouldn't be going up, but I would be going down. How many units?
How many? Can you count? 6.
6 units. So I went down 6 units. So that's not a positive 6, but a what? Negative 6. And then I'm going to go to the right 3, and right 3 is a positive 3. And what is negative 6 divided by positive 3 going to make? A negative divided by a positive makes a negative, and 6 divided by 3 is simply 2.
-2. Yes, I got
So
it.
the slope is negative 2. So that tells you that it's going down at a rate of negative 2. Okay.